Hi, we're Team T.
I'm Tim.
I'm Erin. I'm Emily, hence the name Team T.
Aww.
Our project is called Asset Identifier, and I'll explain. Oh.
Team T.
A nice height. Okay. Our project is a little different than everyone else's project. We didn't have a website or anything, but we had really cool stuff that we were working on in the back end. So our project was to classify 3 different car images. Dealership images, which are an image of a car with a dealership in a background, usually in a parking lot or inside the dealership, and there's usually text such as Buick, GMC, Toyota, Ford, etc. A stock image is just an image of a car with a white background, your standard. And there's placeholder images, which websites use if they want to show off a brand new car that they have, but they don't have an image available. So it's usually just an image that says, coming soon. So we worked on this project to help advertisers sort through images by image type and by image color. So if you look on Ford's website, they have all of their cars organized and they are using stock photos. But for a different website, such as Park Place, the first car that they have, this is a dealership photo, but it looks like they don't have an image available for the 720 McLaren. So they just have a placeholder image saying coming soon. So in the future, it will be helpful for advertisers to know what kind of images they have populating different websites. So we utilized an open source deep learning for Java library to train a model with a distributed deep learning network. And with over 18,000 car images, we use a VNet multi-layer network to train our model and saved it in a binary file. And we created different models based on the first images that I showed you of the dealership stock and placeholder. But as an extra part of the project, we also created a model based on car colors. So our main project, Asset Identifier, receives a request to take in an image in the form of a byte array, and it uses the model to return what kind of image it is with a list of confidences. And the above project calls a side project called Asset Text Detection, and this project uses a Docker container that utilizes Tesseract libraries to return text that's within that image. So an example is we put an image through our program such as this that says photo coming soon, and what our program will output is what it predicts the label will be. So this is pretty confident that it is a placeholder image, and you can see that it's over 99% confident here, and it also returns text such as photo coming and soon.
Which one?
Yeah, I can do that.
Thanks. This is an overview of how text detection works. So basically, the image is first passed in as a byte array, and then a convolutional neural network classifies the image. So here, the highest confidence is placeholder with 63%. And if that confidence is higher than 85%, it would just choose that confidence. Otherwise, which is the case here, it would extract the text from the image. So the text it extracts here is new arrival images coming in soon. And it matches these against keywords for different classes. So this would hit coming and soon in the keywords for placeholder. This is an example of how the process works for text detection. So we start with our original image, gets turned to a byte array. Then it becomes grayscale for the next step, which is a bilateral filter, and this sharpens the image, which makes it easier to read the text. Then each text detection actually locates the text from the image and puts a rectangle around it. Then once that happens, then the text is ready to be recognized by Tesseract, and then the text extracted from this image is Jeff Wyler Chevrolet grand opening discount. So we got all the main text from this image.
So now for our demo. So like we said before, our project doesn't actually have a UI. So we ran an one of our integration tests, which really just kind of shows what's going on behind the scenes. So in reality, this is not very big.
Got it.
It's not working.
I like
Is that better? Okay. So in reality, what is really going to be returned is just like the predicted label, but this just kind of breaks down everything that's happening. So for example, this is for image 14. It shows the predicted label, and then which is placeholder, and then it shows the confidence levels it has for dealership, placeholders, and stock. And as you can see, it's not very confident for any of them. So in this case, it did use the text detection, and it was able to find these texts like arrived, vehicle, coming, and soon, and then it was from there able to classify it as a placeholder image. So we were able to run 100 dealership images, 25 placeholder, and 100 stock images. And these are the accuracies that we ended up with, which were much better than without our text detection. So dealership actually didn't improve that much because by default, it was always going to be dealership if it wasn't confident enough. But the placeholder and stock really did improve. They were only at around like 50-60% accuracy. And then when we added the text detection, placeholder obviously is not 100% and stock is at 85%. So that was really cool to see. And then this right here is actually a really good example of how our program was smarter than we were. So we actually thought that this was a stock image, and the program predicted it as a dealership image, specifically because of the text that it found. So that was kind of cool for us to see that we were wrong. This is a really good example of an image that would have originally been classified as a dealership image, specifically because, as you can see, the confidences are not very high. None of them are above 85%. So it would have by default classified it as dealership, but it found the words photo, available, and no, and because of that, it was able to detect it as a placeholder. And this is another really good example of an image that would have been dealership, but with the text detection, it didn't find any text, and that is very characteristic of a stock image, and so it labeled it as a stock. So one of the issues that we had with text detection is it's really bad at spelling, which is something that we're hoping to, if we had more time, we would look into more, actually improving the text detection part itself. The problem is that it's like a model that comes pre-trained, so what we would have to do is more kind of dealing with the image itself, trying to like change the contrast or something about the image so that it could find the text better. But with regular expressions, we're actually able to kind of be more forgiving with the spelling. So if it's off by a letter, then we're actually able to, like for this first word up here, like midge is supposed to be image, it actually would detect that as image. Because if it's missing a word, missing a character or added a character, it still will detect that correctly. Yeah, that's what we got.
Are there any questions about our project? Yes.
Are you guys looking at the metadata in the photos in order to like copyright or look at in order to figure out if it's a stock image?
No, I think that what we're doing is actually going to be used to like help with the metadata. Basically what we're doing is we're not actually given any information. We just train our model based off of folders that we've already classified images into, and then we like give out a prediction based off of that.
times like 480 and then converted to byte, so pretty big.
So you're,
Yeah.
so your model's taking in the entire image, not like a sliding window?
No. I don't know what you mean by sliding window.
Yeah,
So there's a couple of ways you can do image analysis with machine learning. One is you take the image, you scale it to some known size, you fit your model, and then you pass that into the model.
Oh yeah, ours is scaled to 100 by 100.
Right, so then that's how you're gonna do it. The other way you could do that, and this is used more for finding stuff in images rather than actually identifying a single image, but that would be to take chunks of a photo, split it into basically a sliding window that you kind of view a part of the photo and you compare against that.
That would be better for like text.
Yeah, that
than
might help
actual
with the
image.
text stuff and maybe like identifying objects inside of an image.
Yeah.
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 Yes.
What did GL4j give you that some of the other standard Python frameworks didn't provide?
DL4j gave us a way to train our model based on files that we pre-uploaded. And looking at other, did we look at other projects?
There were other libraries that we looked at, but one of the big issues we ran into was a lot of them were like in Python, and
Most
we
of them
were
were
told we
Python.
had to use Java.
This is like the
That
best
was
one
kind of
for
limiting.
Java.
Oh, you were told to use Java?
Yes.
Yeah.
Oh.
Yeah.
Yeah.
That's weird. Do you know why?
So did you guys evaluate any like steganographic analysis? This goes back to what Doug was asked. Text actually embedded in the image to provide things like date stamping or watermarking or anything like that. No, okay, that's fine.
Yeah.
So you look at image, so what is the best color selling in USA for the car, for the color?
The most popular colors are black, gray,
White.
silver, white,
Yeah.
blue.
A
We
lot of
spent
colors.
several weeks manually sorting through those folders because in order to train the model, you have to give it large folders of cars that are blue, and we had to manually look at 18,000 images in order to do that.
Let's just say we'll never look at car colors the
No.
same.
We're in the process of getting colors to work, but we don't have the accuracies at the same place as dealership stock and placeholder. Colors like yellow are at 100% accuracy because yellow is a really clear and distinct color, but colors like black and gray and silver are around like 20 to 30% accuracy because a white car can easily look like a silver car and gray and black can look similar in various lightings, so it's really hard to train the model in that way, but we're still trying to improve that. Yeah.
Tell us about your issues with Docker.
We have a lot.
we all individually had issues with Docker. One of the issues that we had was, like I mentioned earlier, our main program is Asset Identifier, and the side program, whoa, there we go. One second. The side program is Asset Text Detection, and originally I was trying to get Docker to work with Asset Identifier because the reason we were using Docker is on the Docker container libraries such as Tesseract or the libraries that we use to extract text from the image. Those wouldn't work on our local computers, and Tim and I tried downloading like a bunch of different libraries. At one point I tried to use like a Google API key and that didn't work. But the text detection was working on the Docker container. So I was trying for a whole week to try to get Docker to work in Asset Text Detection, but it just wouldn't work. And eventually one of our mentors came up with the idea of splitting up the projects so that Docker would work in Asset Text Detection, but not in our main project. So we only use Docker when we have a low confidence of under 85%, and we have to call that Docker container in order to get text. And these two had many other issues.
Yeah.
How many percent, if the photo is coming soon, do they can sell, or they will be, how many percent they can sell without a photo?
Can you clarify your question?
Okay, if the car have a photo, it sell faster than the dealer don't have photo?
Most likely, yes.
We don't have data on that though. Yeah, that wasn't really the scope of our project, but.
But maybe they could use your recognition to kind of try and find those metrics, and they could compare it against click-through rates and engagement on
Yes.
vehicles,
Yeah.
because
That is
now we have
possible use
insights
case for it,
into.
yeah.
Yeah, so, but we may not have been able to capture that metric before, to
Yeah.
make that association between the image and the car sales.
That is true.